Hello, my name is Max. Welcome to my Nucamp portfolio project. I've developed a web application that functions as a mini CRM that automates the revenue recognition process for accountants. I'm not going to go into details about what revenue recognition entails. However, if you'd like to learn more, feel free to look through the README file on my GitHub page. This application, currently named INVOISYNC, has been developed using Python's Flask web framework, a Postgres database, SQL Alchemy for object relational mapping, and Alembic for database migrations. This application is then later deployed on Microsoft Azure. Now here in Microsoft Azure, we have an INVOISYNC resource group that contains a Postgres database, a container registry, which Docker is used to build, tag, and push an image to, as well as a Kubernetes service that is used to deploy the application. Within the application's Docker file, we have a base image from Python 3.10 Slim. We're copying over the app directory and installing some requirements from a TXT file. Finally, we run the Flask CLI command to actually start up the web server. Within the requirements themselves, we had everything needed to actually run Flask, handle object relational mapping, database migrations, and any other interactions between Python and Postgres. I have Gunicorn here currently commented out because I'm using Flask's built-in server while developing, but I understand that this might be the best solution for a more production level environment, and it's on my to-do list to add eventually. Now within the Kubernetes deployment YAML file, we have a configuration that defines a deployment for the application that pulls the INVOISYNC v1 image from the Azure Container Registry, exposes port 5000 within the container, and sets some container environment variables to manage the database connection. We also have a load balancer service defined that is listening on port 80 and forwards all traffic to port 5000 on the pods. Next, with regard to the application's overall structure, logic, and configuration, we have a models.py file that is using SQL Alchemy, allowing us to use Python classes to define our Postgres tables. If you'd like to learn more about which tables I'm using and the relationships between them, I suggest looking through the README file for more details. Each defined table then has its own corresponding API endpoints used to perform basic CRUD operations, as well as some more advanced proprietary business logic. Each of these API files has a blueprint that is defined and then later configured to the main application in the init file. While initially developing and testing this application, everything centered around JSON payloads and returning JSONified information from the database, and viewing that all within Insomnia. However, as I worked on a front end, I quickly realized that that's not how it's necessarily done in the context of a web page. This forced me to have to rewrite my entire backend, straying away from the constant use of JSONify, and rather implementing built-in Flask functions such as render template that allow me to pass through an HTML file and assign variables defined in the API endpoint function. These variables are then used in the Jinja 2 templating language within the HTML file, allowing me to dynamically display any data from my database. Finally, we have a few ways of demoing this application. Since I tried to add a front end and had to rewrite a good portion of my back end, a process of which is not fully completed yet, a portion of this is only testable in Insomnia, while the rest is testable through the load balancer's external IP. Let's first test the application using the load balancer's external IP. This will allow us to create, update, and view customer records. We can then move on to Insomnia to create contracts, transactions, invoices, and see what the accountant tool is useful for. Welcome to the first iteration of INVOISYNC's front end. It ain't much, but it's honest work. And the only working link right now is the customers one. This will bring us to a page where we can create a test customer. And view it in the corresponding table beneath it. We can also update this record. This updates the HTML as well as the database record. We can then view the record. We currently have no contracts or invoices, but we will now move on to Insomnia to get those created to see what this functionality also looks like. Now within Insomnia, we can use a JSON payload to create a contract for the Nucamp customer we just created. The contract here is for 1 year from January 1st, 2024 to December 31st and totals $12,500. We can then go to the transactions endpoint and using another JSON payload specify the contract ID and the various transactions within that contract. Note that transactions can be different products, different amounts, different start and end dates, and different billing cadences. That being said, the combined total of all transactions for a contract must tie to the contract's value. Additionally, the start and end dates must fall between the contract service periods, otherwise an error will be returned. Since this contract's transactions were created properly, we can move on to create the contract's invoices. Here we just need to specify the contract ID. It then iterates through each of the transactions within that contract to determine if those transactions have any similar invoice dates. If so, it couples those product items onto the same invoice. Back on the application's webpage, we can now review that customer's records, and we should now see that we have one contract and all of the invoices necessary to satisfy that contract. And what we can actually do here is we can click on one invoice and it'll show us all of the transactions that are included in there. Now, there are a few errors here where this is specifying the whole amount of the transaction, while this invoice only contains a portion of each of these transactions. So that is something to be worked on in the future, but right now this is the basic functionality of the user interface. The final functionality to review is the accountant tool. Currently there is only one, a revenue by product by date range query, accessible through a JSON payload that specifies the start and end date. The application uses these dates to query transactions within the date range. It then reads those service periods and the transaction amount to determine only the amount of revenue to be recognized in the queried date range. An accountant could then use this tool to use the returned information to build a journal entry to recognize the proper amount of revenue on a monthly basis. Overall, it ain't much, but it's honest work, and there's a lot more to do. It's been a challenging yet rewarding experience, and I greatly appreciate all the support and guidance from Nucamp's instructors. They've been great, and I intend to work on this even after Nucamp.